Is an example of a problem involving the central limit theorem. So again, we have our exam scores, which are normally distributed with a mean of 80 and a standard deviation of 5. Suppose a random sample of 40 scores is selected. Find the probability that the sample mean is greater than 85. So in this case, how do I know I need to apply the central limit theorem? Because I've taken a random sample of a certain number of scores, in this case 40, and I'm asking about a probability involving a sample mean. So this is how I know I'm about to apply the central limit theorem. The reason that's super important is because if you don't stop and think about that at the beginning, you will probably be tempted to use the wrong standard deviation in your calculations, and your problem will come out wrong. All right, so here we go. We're going to draw a picture. I know that the sample mean distribution is going to be normal. How do I know that? Because we have a large sample size. Remember, we have a sample size greater than 30, then I know that the sample means will be normally distributed. The center is going to be the same as the population mean. However, the spread is not going to be 5. The spread is going to be given by this formula, standard deviation divided by the square root of sample size. So in this case, 5 divided by the square root of 40. And if we just grab a calculator and do that, that comes out to be 0.79. Now this spread is called the standard error, and we abbreviate that SE, but it's really just the standard deviation of this picture. All right, so let me go ahead and draw what we're looking for now. So we want the probability that the mean of the sample that we just drew is going to be greater than 85. So we're looking for this area here. So one of the things I might notice, and it's okay if you don't notice this in advance, but one of the things I might notice that if I were to draw this picture to scale, so here's 80. Remember that one hop over would be 80 plus 0.79. So this should be 80.79. 2 hops over, this would be 80.79 plus another 0.79. So I'm just calculating that for us quickly. So that would be 81.58. And by the time I get to 3 standard deviations, that would be another 0.79, so 81.58 plus another standard deviation. Now, you don't have to do this. I'm just drawing you a picture so that when we go to the next screen and we get our answer, it's not going to be surprising to you. So 3 standard deviations, in this case standard errors from our mean, is only at 82.37. So 85 is way out here. So what am I expecting my answer to be? I'm expecting my answer to be 0. In other words, if this is truly the case, it would be almost impossible to take 40 exam scores, take the sample mean, and get a number greater than 85. So let's go ahead and use our calculator and just confirm that. Okay, so we go to our online calculator, and we're doing a normal distribution problem, so we're going to come and get our normal distribution calculator. The mean is 80. Now this is why it's super important that you remember you're doing a central limit theorem problem before you pick up your technology. Your technology is always going to prompt you with the abbreviation SD. It's not going to change it to SE to remind you, oh, you should be using the central limit theorem. You need to remember that yourself. So that's one of the reasons I always draw a picture and think about what I'm doing before I pick up my calculator, because otherwise you would be tempted to put a 5 in this box, but instead we need to put 0.79 in that box. And we want the probability of being above 85. And when we calculate that, notice it comes out to be 0. And you can see that in the picture, it provided the scale that I was providing for you in the drawing that I was making. And you can see that 85 would be off the chart to the right. So in other words, very close to 0. Let's take a look at another question. Same exam. Can we find the probability of a sample mean greater than 85 if we're only taking a sample of 4? So in the first case, we just jumped in ahead and said, let's use the central limit theorem because we had a large sample size. But now we don't. Can we still find the probability? Well, the answer to that is yes. Why? Because we were told that the distribution that we're drawing from is normal. If this word was not in the problem and we didn't know anything about the shape of the distribution we were drawing from, you could not do the problem. We would need a sample size that was larger than 30. But in this case, since I do know that the population is normal, I can do the problem. So we would do it exactly the same way. The mean is 80. I would have to calculate the spread using the formula standard deviation divided by the square root of the sample size, or in other words, 5 divided by the square root of 4. And that comes out to be much larger. That comes out to be 2.5. So in this case, if I were to draw a picture, one hop would be 82.5. Adding on another hop, oh, that just coincidentally comes out to be 85. So you can see that that area is not going to be 0. And we would do it exactly the same way. As a matter of fact, some of you might be able to predict what that answer is going to come out to be just from what we studied about the empirical rule. But let's go ahead and give it a try with our calculator. Okay, so the mean is 80, but now our spread is 2.5. So we have a wider spread. And again, we want above 85. And we'll calculate, and that comes out to be 0.0228, which we will go ahead and record. 0.0228, or about 2.28%.